In this video, I will explain how to submit a simulation job to the Sol cluster so that the simulation can run. Uh, then I'll also briefly talk about how to use interactive mode. So let me connect to the Sol cluster first. I created this alias. If you're not sure about what the alias is, make sure to check my previous video. And I won't repeat all this. I won't repeat all this explanation again. So this is my alias. Your alias might be different. So I am on the Sol cluster. So then let's first go to the Scratch folder. Like I said, explained in the previous directory, you always need to go to the Scratch folder. This is my Scratch folder. Do not try to access here. You need to have you should have the Scratch folder by replacing this my ASU Ride ID by yours. Okay, so I want to go to the Scratch folder, and what do I have here? This HIT. So I'm going to go into the HIT, and so I have one folder I already created. Use auto completion by pressing tab, and then what do I have? So 32. This means a 32 cube grid simulation. Check my previous video. So in my last video, I explained how to does a few items in the input file and how to find the information in the source code. That's something you need to do first. Then if once that's done, it's time to submit a job, okay? So that you can run the simulation. So to do this, you actually need a couple of things. But before you do this, make sure to check this Research Computing Confluence page, okay? Research Computing made this Confluence page. Here is the address, but this could be different. But if you ask these guys, they have the Slack support channel in which you can ask those questions interactively and talk to some of the research computing personnel. They did an excellent job in creating this page. This page does not have all the information, but this has all the useful information. So then, before you do the job, the submit a job, make sure to check this content. And there is a one item for Agave cluster, which will be retiring pretty soon as of 2023. And you want to check this Sol supercomputing, okay? And there are many other information, additional information. I don't know what they have. Some policies and external resources. Usually these are quite useful. Check, press the Sol cluster. Then there is a new user guide for Sol compute resources. You want to go over this thing, okay? Then you have a connectivity and file transfer and everything about SSH and so on, downloading and so on. So there are many items, but under the new user, no, wait here. Yeah, under the new user. So I believe if you scroll down, there is a way to submit a job. I remember so how you get the account, which I already explained, and how you submit a job here, submitting jobs in batch. There are two ways to run the simulation. You can use the interactive mode. You can use the batch mode. So you need to go over these two, okay? How to interactively submit a job. Say, I'll go over this thing. Then I think it's under connectivity, right? Yeah, here. Connecting. Oh, wait, no. This one. Yeah, starting interactive section. Anyway, in this new user guide, they have everything. So make sure to go over everything and follow this thing. And VPN, transfer file, run batch in all this information. So there are some information that may not familiar with, but you want to go over everything several times so you can understand how to reduce this Sol cluster. So if you click the batch, then I think it's using the Sol cluster, okay, scheduling. So there is an example about how to set up this batch script. You want to go over everything, okay? So it's not the preschool or elementary school. You need to go over all these new things yourself and ask questions, okay? Instead of asking somebody to explain everything until you understand that what you do in the elementary school and or junior high. So obviously there are a few things that you cannot understand definitely yourself. Then you want to ask questions, okay? Then there is also some the basic information which you need to know in this partition and the quality of I think service. These two are important, and there are many other important items too. But I'll go over this thing. But my point here is that in this Atlassian the site that the ASU Research Computing developed, they have all the precious information. Okay, let's go back to terminal. So here I already prepared this input file, which I explained in the last video. Now I have this batch script. So let me explain briefly. So I want to show this content. So I have the first, this is another shell script ending with extension of sh. So this is it is follow the bash scripting. I don't think this is really important, but maybe this export and comment may be affected if you choose a different shell. So again, go over this the Confluence page because it has the information about the partition. So you see that there's a -p. So if you need, I think you need this thing. So if you choose the general, by the way, you have other options, general, HTC, and HiMem. Then depending on your purpose, you want to specify the different partition. If you don't use anything special, then general is fine. But if you want your simulation to run faster, then you want to choose the HTC, but you only have 4 hours of the runtime. Okay, HiMem meaning that if you want to use a lot of memory, then this is a partition that you need to choose. And Q is the Q, quality of actually not the Q. It's quality of service. So usually it's a public, and so another option is debug. If you want to debug the code, then this is probably something you need to use. Not sure. Maybe debug queue has a shorter runtime, maybe an hour. I don't know. If you need to run your simulation for a long enough time, I believe if you scroll down all the way to the quality of service here, there's an instruction about what each queue indicate. Public, debug. I think debug is supposed to have a shorter runtime. Oh yeah, 15 minutes. Okay. Then private, we don't use the private, not the lab. So if you need to run your simulation up to 14 days, then long queue is something you need to use. But there is a smaller number of the long queue, so you need to choose. Okay. Then these two lines, basically, if you run your simulation, whatever your simulation is spitting out will be recorded in this the job ID .out. You can change the name. It's up to you. Then if the simulation say starts, stops, or fails, it's going to send an email to your ASU email. Okay. In my case, I specified all, but you can choose something different. Not sure if I have instruction about this, but so then the following the item SBatch starting with the pound SBatch, it's specifying the email address. This is mine. Do not specify my email address here in your script. So then -J is the job title. This is what you see if you type SQ comment. Oh, okay. So I'm showing everybody's. So in this case, and I want to graph only my job. Okay, I'm not running anything, so I don't see any error any job title. But if you see, I think which one is job title? Does anybody has a job title? Maybe not, but I'll show you. I'll show you later. Okay. So let's look at the job script one more time. This is job title. You just name it differently so that you can distinguish your job in case you submit many jobs. If you submit many jobs, then you definitely want to distinguish which one is which. And this dash n is important. How many processes you're using? I have 84. Okay, I'm using 84 processors. And how do I get this number? Go back to input. Remember this number 84. So here, if I go up, then here I specify the partitioning, how the domain is decomposed. So I'm using 7 processes along the x direction, 4, 3. So if you multiply these 3 numbers, which is the 7 times 4 times 3, then that's going to be 84. You want to match the product of these 3 numbers with what you see in this JavaScript 84. And dash T is important, basically in the format of day, hour, minute, and second. So here in this particular case, my maximum number of hours is 24 hours. But if my simulation stops before that time, then this is just the maximum allowed time. I'll explain what this script does. If you submit this JavaScript, what's going to happen is that it's going to move to the present working directory. This is an environment variable, and this contains information where the JavaScript has been submitted. I'm going to explain that later. I'm going to do that later, but basically, so my current directory is this one. So then if I use the sbatch command, this is how you submit a job. So J autocompletion. If I press enter, then this directory will be stored in this environment variable, $PWD, present working directory. Okay. So ignore these 2 things because they are commented out by having this pound sign. So in the case of NGA, you can do it in a number of different ways, but my suggestion is given in this example files. I'll explain that later. So to run the NGA simulation, you need to do 2 things. First one is to run this init_flow so that your simulation can be initialized. The next code you need to run is this Arch. I think this is Advanced Reacting Turbulence Simulator something, Arch. But this is the executable file of NGA. This Arch is actually NGA. So then my suggestion when you run the NGA simulation is to run this init_flow in the interactive queue. So you check everything is running, everything is initialized correctly, then you submit a job. So that's why I commented out this init_flow input, okay? So of course you can include this initialization in your batch script, but if something goes wrong with the initialization, your NGA code, which is Arch, won't be executed. So if you are in my group, follow my suggestion, run init_flow in the interactive queue, then you run the NGA. So then I'll first explain how to do the first step, okay? So I'm going to clear screen. So the first, what you want to do is you want to run the init_flow in the interactive queue. Oh, it should be J. So let's run the init_flow in the interactive queue. So to do this, interactive -n, say I want to grab the 2 processors. I have a -n2. What this means is that I'm going to use an interactive queue and I want to request 2 processors. You can increase this number as many as you want, but if you ask too many, you have to wait a lot of times. So again, okay, I usually don't have to type the password, but if you see this message asking password, you want to contact the research computing. So now I'm in the interactive queue. Then what I'm going to do is I want to execute this init_flow, okay? So how do I execute init_flow? Before you do this, remember I defined this alias so that I can set up everything so that including the loading the module. So if you don't remember what I'm talking about, just watch my previous video, scripts code, and I forgot this nga. Yes, so you can include in your bash RC file, but at the same time you can create this nga.sh file, and you keep it here in the particular directory. Then you simply run this thing. So I created this use the nga command. Now if I run it, and this shell script will be executed, and I'm ready to install and run the nga. So basically, by typing this command, I executed everything here. So I set up the path so that I can access to the binary file folder of the nga, and I load all the modules. Okay. So then, so let me run this init flow. This init flow can be found in your source nga, and I think it's a bin. So you see that there is an init flow if you compiled everything correctly. If you don't see this file, that means that your compilation didn't go well. So I can execute this init, then underscore, then you want to press the tab key so that you can do the auto completion and type input. Okay, you can run it. Then it runs almost immediately because this is a 32 cube simulation. So you can scroll up and check what you have here. So this is a homogeneous isotropic turbulence case. So it reports all the quantities. So you want to check the DNS underscore box.f90 in the tools init flow. And all these things have to be consistent to your initial spectrum, which is a Paso Bouquet spectrum, capital PP. So if you want to, so this is what I did. And after running this, you see that the config data init and optional data init and all the spectrum analytic, which is a Paso Bouquet spectrum, and the spectrum they generate, the nga generated and numerically is written. These two have to be the same. The spectrum analytic and spectrum numerics should be very close. And the code writes some of the output. So another way to do it is to use a pipeline, meaning that, say, you want to use the upper arrow key. So this is what I did. So the message is written on the screen, but if you use the, say, this is basically pipeline, the direction of the information. If you press enter, then nothing is shown, but everything is recorded in this SCR file. So that so everything is stored in this file. Okay, so if you use a VI editor, then you can see that the screen somehow becomes smaller because we are in the interactive queue. This happens. I used to know how to fix this, but not right now. So the later, if you want to check this all the variables, you don't need to rerun this thing. You can just look at what you have in this SCR file. Okay. So let's go out, exit. So now I'm out of the interactive queue. So, but still I have this config file, initialization file, and optional data file. Okay. Then what's next? So now that I initialized, I want to go back to this input file and emphasize that these files are created. This except for this particle file, every file is created. And now make sure that you specify this config file here, and this data file here, and optional data file here. But if you restart your simulation, you definitely want to change this name. So let's go out. Then I did the initialization. That was the first step. So instead of including the init flow in my JavaScript, I have run it in the interactive queue. Then the second thing you want to do is that you want to copy CP, this thing, your the nga executable file to the current directory. Of course, you can instead of having it current directory like this, Of course, you can copy and paste this path here so that but there's actually one issue, and in case that you're running many cases, sometimes you want to change the source code. So it's better to have your local copy of the executable file in your current directory. So if you're not sure, if you don't understand, follow my suggestion, okay? Then you're going to be able to see why this is probably more safer. It's a safer than the anyway, so this is what I have. So I copied arts. So the next thing you need to do is simply submit the job as batch in JavaScript. Okay, let's submit it. And I have a job number. If you type SQ, okay, I have to grab my own. So you see that you can see that the job is running. How do I know this? This is my job ID. I'm in the general queue as I requested. CSM32 is my job title. That's my ASURide ID. It all means running. Q, if it's a Q, then is it Q or PD? I forgot. I think PD is a pending here. I'm not 100% sure. Then it's been running for 7 seconds. Yeah, and maybe this is the node, but you probably don't need to know. It's actually that's my alias, but so the way you do it is that you can check this slum file, output file, and it's actually running. You can see that the message is written here. It's actually running quite fast. And if there is any error, then it's going to be showing up here, .err file, which I prescribed here. You can change this name if you don't like this name, Slurm, then you can pick something else. So then I want to check the file. If you're not sure what the tail is, find it yourself in the internet. You can just Google like a Linux and tail, then there will be maybe 10,000 different pages explaining what this comment does. It actually shows the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the last 10 sentences, 10 lines of the text file, okay? If I repeat it, and you see that there is a time advancement. The last time step was a 45, now it's a 57:30, okay? It's running quite fast. So then I want to stop this thing. I want to cancel and type job ID, and it's canceled, hopefully. Yeah, it's currently being canceled. Okay, it's currently being canceled. It's going to be going away pretty soon. So this is how you run the simulation. Make sure to run your simulation in the Scratch folder and follow my suggestion about how to initialize code. You want to run init flow in the interactive queue. You want to copy the ng executable file arts to this directory instead of running it from the source code directory. There's a particular reason. I'll explain that later, maybe in person. Then frequently check the simulation status in case it's blowing up. Yes, it's gone. Okay, so this is everything I have. Then hopefully I can make another video, but probably this is going to be everything you need to run NGA code simulation.